Hello, everybody. I'm João Longo. It's my pleasure to welcome you to Encora Talks. Over the next 30 minutes, we'll talk about feature environments for achieving fast delivery in the world of technology. Now, a bit about myself. I have 10 plus years of expertise in system architecture, software development, and technical leadership. I made significant contributions to various technological domains, notably in microservices and web development. My career is highlighted by my role as distinguished member of technical staff and my commitment to innovation in systems architecture. Without further ado, let's jump into the presentation. Okay, so here is the schedule. We'll talk about fast delivery, feature environments, release process, key points to consider, and finally some references. Let's start with fast delivery, some considerations. So we have a couple of questions here. It's important to answer them. And the first one is why to deploy faster? In this world of technology, it's very important innovation and time to market. Also, it's also important to do some experimentation quickly. And that's why it's important to deploy faster, right? So next one, how often do you want to deploy to production? Let's say you want to deploy weekly or even daily or as soon as possible. So, okay, we answered two. Let's go to the third one. Can you deliver your changes faster? It's important because your product or your project may not allow that. But let's suppose you can. You can deploy faster. I want to deploy daily, right? So, next question. Do you have microservices or a monolith? With microservices, with this process will be a bit simple. With monolith, it's also possible, but there can be some complications due to the nature of the project. And also, finally, what's the tolerance for production bugs? When we deploy faster, there are a bit more chances of bugs happen. Of course, we will take many actions to control that, but still possible that you have a production bug. How is your tolerance? Or by you, I mean your project, your company, right? So there are some important things to consider in your project before you decide to deploy faster. Are there automated tests? Or no? Or just manual? What's the percentage of code coverage by tests? It's high, it's low, right? It's important to have a high coverage. Does your project have a rollback process? If something goes wrong, how would you roll back your deployment? Does your project have feature flags? If a new feature is not working properly, is it possible to quickly disable that instead of rollbacking the entire deployment? Do you have monitoring observability configured in case your tests are passing, but there is something happening behind the scenes that only monitoring shows? Are you able to check them? Okay, so it's important to take all of these in considerations when we talk about fast delivery, right? So let's talk a bit more now about feature environments. Now we made the considerations. Let's define and give you an example of feature environments. Okay, definition. A feature environment is a feature branch deployed in an ephemeral environment, which enables automated tests and QA to test that feature in isolation before deploying to production. Okay, let's see a bit more. This is the idea. So we have the feature environments. We can see them in this proposal as a separate stage environment for each feature branch, allowing fast delivery of features. So we have the feature branch 1 here that the developer worked on them. We have automated tests that runs against it, and also finally QA to do some final checks. Same thing for feature branch 2. which end up being the feature environment 2, and so on. And when we approve one of them, they go to production. That's the basic idea. Okay, I gave you a basic idea, the basic idea. Let's take a look on an example, and then we can apply feature environment for the API of this example. So I have an example system, pretty simple. So we have the mobile app, a mobile app that accesses an API, example API. And this is production. We have the API uses a database and uses a cache. The database is called ExampleDB. An API and the mobile app accesses the API using the address api.example.com. Main branch, main branch. So this is the idea of this example system. How can we apply feature environments to this system? So we are going to see now how staging would be. The first thing important to notice is we still want like a main staging. The main staging represents the code from production, the semi-code then production, right? So it's still main branch. And the main staging is the second part in the figure here. And it has also access the example DB, the cache, and the address is staging-api.example.com. It's important that we have the mobile app that accesses by default staging, right? But it's important that the mobile app should be able to use any environment or any address, any API address. So in the mobile app, there can be a panel, a debug panel, where you can set the API address. So let's say you already have that, and you are able to point the mobile app to another address. And then let's say, for example, we have a feature environment. The name of this feature environment is EXMP1. It started by when a developer started working on a task EXMP1 capitalized, which is the Jira ticket number, right? And then he created this branch, EXMP1 branch, creates a pull request, and then automatically we created this ephemeral environment here. And this ephemeral environment, the name of it is the branch lowercase. This is important. Another thing that's important, the name of the branch should be URL friendly, because as you can notice, the name of the feature environment appears in front of the staging API. In case you have a slash in the branch, you can replace the slash by a dash, for example. But it's important that the name of the feature environment remains URL friendly, right? For this case, we are using a separate cache instance. And for database, just because it's easy for this case, I'm creating a new database with the name of the feature environment in front of the database name. But I could also create a separate instance for the database. But this is usually more difficult. That's why in this example, we are using this way. All right, so this is the architecture of feature environments for example API. So just to recap, the mobile app can point to any environment, and then I can go to the bug menu and point to this another environment, and that it's how feature environments would work here, the staging, right? Okay, some key points. The main branch should only contain stable code. The main branch represents the current staging, the main staging, and also the current production. URLs, and it's important to keep the URLs friendly with, using feature environment names that end up creating friendly URLs, because if you add a slash there, you can have issues. So URLs are important here. You can keep isolated resources. If we return here, we have an isolated cache, an isolated database, and also an isolated API. Everything is isolated. API configurations. With this, setup here, it's important that your API allows overrides for the cache address, database name, etc. So this will facilitate a lot. It's pretty easy. So you don't need to build every time. You just can use an environment variable and replace the address of the database or even the cache and the database name, etc. So it's important this flexibility for configurations. And finally, the main staging. It's important to keep a stage environment, which we call it main staging, that reflect exactly production. This would be important in case you need to do some performance tests or other things, or just check if a bug is also present in the lower environments, right? Okay. So we can propose a release process using feature environments to deploy faster. That's the idea. So this is the release process. It has two parts. Let's consider first part one. Remember that task the developer was working on? Okay, here let's do one step back, and the developer didn't start the task yet. So now the task exmp1 is ready to be implemented. So the developer can start doing it. So number two, developer implements the task in feature branch exmp1 and creates a pull request to the main branch. 3. Build pipeline. We build static code analysis, unit integration test with coverage check. 4. Deploy build in a new environment called exmp1 lowercase, which is the name of the feature environment. 5. We run end-to-end tests against exmp1. Let's say everything is okay, the test goes to code review. Another developer can suggest some changes. If that's the case, everything returns here. So developer implements new changes and build pipeline happens, deploy feature environment, run end-to-end test, code review, and then now it passes. Task is ready for QA. So QA, let's say a QA person picks it, this task, and can do some final checks. By final checks, I mean you can point the mobile app to that feature environment and just test the solution really end to end. Let's say QA finds a bug, everything returns to the beginning. But let's say it's okay, task is ready to go to production, and task remains ready. And then we go to the part two. Part two, we have the main flow here, and we have some alternate things that happen. So I'm going through the main flow first. After that, I'll talk about the alternate flows. The parallel flows. So let's say that task, the product team approved it to go to production. So task is approved, developer merges the pull request to main, build pipeline, build static code analysis, unit integration test with coverage checks. Same thing. Deploy build in production. Run end-to-end tests against production. QA does final checks in production. Task is done. And also, we have those three parallel tasks here. So when the developer merges the pull request to main, one thing that should happen automatically is destroy feature environment exmp1. Because the feature environment, remember, it's an ephemeral environment. It should be destroyed at some point, and that's the point. Here is the point. When we merge the pull request, or even we close the pull request for any other reason, we destroy the feature environment. Another thing that happens in parallel here, remember, we can have more than one feature environment active at a point. So when we do a new merge, we back merge to all open pull requests. We back merge main to all open pull requests. We warn developers if a merge fails. Right? This is important to keep all other feature environments up to date with the main branch. So all feature environments should continue having the main branch plus an increment of code. And after we build, we deploy in production, and we also deploy main staging. This is one thing. This is a proposal uh, to deploy faster. You can change this a bit, like deploy to stage first, do some final checks there, and only after that deploy to production, etc. And also you may think about, how about if the end-to-end tests against production fail, or QA does final checks in production didn't work? And this, we can go to the next slide, which emphasize important practices. So for this specific case I mentioned, it's important to have a rollback process in place. In case something fails in the deployment, this is the HAP flow, we should be able to roll back it quickly. Or even if it's not the entire deployment that has issues, just a feature, for example, we can have feature flags and just turn that off. So that's why it's important to have feature flags and also an automated rollback process implemented. And going through the other items, remember, focus on automated tests. High percentage of code coverage. It's important to fail the build if the code is not covered by the percentage you defined it. And this is with this one, CI with strong quality checks. If something don't pass, the build should fail. Rollback process, we already talked about that. Feature flags, same thing. Monitoring and observability. After we deploy to production, it's important to monitor and keep monitoring to see if there are issues you're not aware of. And in case you find issues, you can act accordingly. For example, even creating a hot fix, or even rollback. I don't know, depends on the case. So, but this is all ways you can control the risks. We are still deploying. Can you see here? We are deploying pretty fast. It's much faster than a common process, but we are also controlling the risks with all these important practices. Okay, now we see, we already seen feature environments. We see, we saw a release process and some key points to consider, pros and cons about this strategy. Okay, pros. Product management or development team can select when feature goes to production. This is interesting. Sometimes you don't have how can I say, you don't need to plan the sprint. If you use Kanban, for example, it's good, this process, because you can just, okay, something it's approved to go to production, it can go when product team or even the development team wants. So we can select, we don't need to wait a set of features to be done before you go live. You can just pick one or another. Of course, it's important planning, because sometimes we have order of features. So it's important to take this into account. But the thing here is you don't need to plan a set of features to be there, and sometimes when we use a common process like using develop branch, staging, and main branch for production, we stuck on development branch waiting for a final feature that's not ready yet to go live, to go to staging and production. In this case, we can go feature by feature, select it, and merge it to main and go to production. Second one, this encourages short release cycles. Why? Because as you saw in the previous slides, when we have the more pull requests we have open at a time is worse, right? Because every time we can have more conflicts, we have more, we can have dependencies, and etc. So the better, the faster we merge into main, it's better. So the team will indirectly be encouraged to do that. Do it to the the process encourages this behavior of merging faster, doing also small changes, because otherwise you can have issues. Another thing, you can test code in isolation. sometimes when we use the common process of deploying many things to dev and then testing there, you don't know if something breaks, which ticket or which change broke that. With feature environments, we know, because we know each feature environment is the main branch plus an increment of code. So it's pretty simple to know. Hotfix, same thing. Just create a feature environment with hotfix, merge into main, and approve to go to production, and you are all set. Debug, easy. Just create a feature branch, create a pull request to main, put some logs there, and you can see in the remote you can test this in the remote servers using the feature environments, and you have additional logs there. Easy to do experiments. Let's say the product team wants to test a new change in the API or even a new behavior. You can create a feature environment, point the mobile app to that feature environment, and test it. So pretty simple. And in case it's not good, or they want to do another way, just don't do the feature, just close the pull request, and you are done. So that's why it's easy to revert changes. Cons. Okay, this is important. This process requires maturity. By maturity, I mean for people and for project. For project, because all of those practice I mentioned are important to have in the project before you start using this process, right? Otherwise, you can have issues. You can have production bugs, and it won't end well. You need to control the risks, right? And why people? Because this is something a bit different, right? You need to understand how things work, and sometimes people are just use it to a common process of testing dev, testing staging, production, and they are not used to this kind of process. So people sometimes will require a bit of time, a bit of practice until they get comfortable with this process. And this is why I mentioned here also requires practice. The team needs to be comfortable with this process. Okay, another con, it's complex to implement. As you can see, every time I create a pull request, automatically creates a new environment with a new database, a new cache. All of this can be a bit complicated to implement. One thing that helps a lot here is using GitOps. If you use a GitOps strategy with Kubernetes, it can facilitate a lot. Environment costs. With more environments, with more pull requests, more costs. Of course, you want your feature environments to have a low hardware usage, but even that, there are more environments, so more costs. Requires more communication planning. It's important to plan the order of the features sometimes, right? You don't need to wait until all of them to be ready, but in most of cases, you need to plan the order, especially when there are dependencies. We usually try to create tickets that don't depend on each other, but in reality, many tickets depend on each other. So that's why it's important to require more communication planning. And the last one, I didn't talk about it yet. It's many different stage environments. This is more or less related to the first one because people are not used to this. They can get confused, right? Because they need to use different addresses. The address change every time. So, and that's why, again, the process requires practice, right? So, and that's the cons. Finally, some references. So we have 3 articles, and also the fourth one is essentially this presentation. So in case you want to review this, we have an entire blog post in Core Insights to discuss about this topic. Okay, so this is the content I prepared for today. Hope you like it. We have 2 questions here, and we have some time to cover them. Let me see. Okay, first one. I like the idea of feature environments, but I want to use it with dev stage and production environment. Is this possible? Yes. In this presentation, we consider that feature environments are many stage environments. You can consider them as many development environments and follow your common process. So in this case, we can just insert a new environment. The pull requests don't go directly, the deployment don't go direct to staging. It can go to dev, and then we still have staging and also production. It's just a matter of adjust a bit the process. But the idea here was to present the faster process as possible, but you can adjust accordingly. Okay, there's the second one. Okay, why would it be more difficult to implement this process for a big monolith project? Yeah, that's a good question as well. Yeah, I think I comment this, but for this process, the less opened pull requests you have, the better. With a big monolith project, the chances of having more pull requests opened at a time is higher. So what happened? The chance of conflicts, Git conflicts, will be higher. And that's not good. This will slow down your development. Also, remember, every time we merge a pull request, there is a process that does the back merge main to all open pull requests. So everything, all open pull request starts building again, running end-to-end tests, and etc. That's why it's easier to have small components. So if you have microservice, for example, or even if you have small components, easier because you can have small pull requests and different repositories. You can even use a monorepo. That's okay too, but it's important that you avoid conflicts, right? Okay. So as we wrap up today's session, I want to thank you all for attending this presentation. For more insightful content, remember to subscribe to our YouTube channel. Also, stay tuned for upcoming webinars by visiting talks.ancora.com. Thank you. Bye.